So who remembers what we were discussing last time? Anyone remembers? Wants to recap what we did last time? We were doing plots, right? Graph of some from equations. Which equation did we plot?
X square plus y square plus z square equal to 1.
Yeah. And what does the plot look like?
Sphere, sir.
Yes,
Yeah.
sir.
Yeah, it is a three-dimensional plot. So you cannot do it on a paper. You need a three-dimensional visualization. And what about x square plus y square plus z square plus u squared equal to 1? What is that? What is that? If you plot it, what is it? We have four variables, then x squared plus y squared plus z squared plus u squared is equal to 1. What is that called? What shape is it? Is it a three-dimensional sphere? So x square plus y square is equal to 1 is a circle, right? It is plotted in 2 dimensions. X square plus y square plus z square is equal to 1 is plotted in 3 dimensions, and it is a sphere. What about x square plus y square plus z square plus u squared equal to 1? What is that? Is it a three-dimensional object?
So it is possible. It is not possible, sir, because we don't have any 4-dimensional.
Yeah, it is not possible in to draw it. That's correct. But if you were to describe it, what is that object? Mathematically, what will that object be called? You can still think of it as so think that there is a circle which is two-dimensional, a sphere which is three-dimensional. So you can give it a name. You can call it hypersphere, a four-dimensional hypersphere. Okay. So we can't imagine it because in this space, in this space, we can't imagine it. Why? Because our mind is not capable of imagining things which are in 4 dimensions. But you can still reason about it. You can still talk about it because you can do things like in the 4-dimensional sphere, what is the diameter, what is the point. You can still in normal sphere you take 3-dimensional coordinates, right? Everything is x, y, z. In a 4-dimensional sphere, you will have x, y, z and u. So you can still talk about a point on the sphere and another point on the sphere. You can take the distance between them. So all those things can be talked about by using the equation. Similarly, just like you have a square which is 2-dimensional and then you have a cube which is 3-dimensional. Similarly, if you have x, y, z and u, then you can get a 4-dimensional cube which is called a hypercube. There also you can talk about the number of corners of a 4-dimensional hypercube. How many corners are there in a square?
4, sir.
4. How many are there in a cube? Cube has how many corners?
So 8.
8, sir.
Yes. How many corners will be there in a 4-dimensional hypercube? How many do you think will be there?
So 16.
Okay, so we cannot even imagine a 4-dimensional hypercube, but 16 is correct. So we can't imagine it geometrically, but we can talk about it by using coordinate system. So in a coordinate system, now think of a square. For square, we have x, y, right? Now think of a square which is whose left lower corner is 0, 0. And then another corner is 0, 1. And another corner is 1, 0. What are the 4 corners of a square? Can you tell me the 4 corners of a square of length 1? Whose one of the corners is at 0, 0, 0? What are the 4 corners? If I put it on a coordinate system, and if my left corner is at the origin, the left bottom corner is the origin, then what are the other four corners? Other three corners? Yeah, Pooja, go ahead.
1 and 1, 1 and 1, 0.
Yeah, so 0, 0 is one corner. The opposite corner will be 1, 1. And the other two will be 1, 0 and 0, 1. Correct? So these are the four corners. Now tell me, when you go to three-dimensional cube and I put the one of the corners at the origin 0, 0, 0, can you tell me the other corners? What are all the corners? So 0, 0, 0 is one of the corners of the cube. What are the other corners? How many corners are there in a cube?
8, sir.
Yeah. So how from 0, 0, 0, what are the 8 corners total? The 7 other corners, right? How will I get the 7 other corners? Total 8 corners. What are the 8 corners? Just tell me one other corner. Can anyone tell me one other corner of the cube? Other than the origin?
0, 0, 1, sir.
Yeah, 0, 0, 1. What else?
0, 1, 0, sir.
Yeah, 0, 1, 0. Exactly. Another?
1, 1, sir.
Yeah, 1, 1, 1. So you have the x, y, and z axis. So this is 0, 0, 0. So you can go along the x axis, and that will give me 1, 0, 0 from the origin. And then you can go along the y axis, that will give me 0, 1, 0. And along the z axis, I will get 0, 0, 1. Okay. But I can also go along the x and the y axis one step, and I will get if I go along the x and the y axis one step, then I will get 1, 1, 0. And if I go along all the three axes one step, then I will get 1, 1, 1. So in total, there are 8. How many combinations are there? I can set each corner to be either 0 or 1. Each coordinate to be either 0 or 1. So the x-axis I can consider to be either 0 or 1. Y coordinate I can consider to be either 0 or 1. Z coordinate I can consider to be 0 or 0, 1. So there are 2 choices for the x, 2 choices for the y, and 2 choices for the z. So how many total ways are there? Yeah, can someone tell me all the 8 of them, the 8 corners of a cube? So there are 4 corners of the square, correct? So just with the x and y coordinate, I can get 4, right? 0, 0, 1, 0, 0, 1, and 1, 1. And I can take all these 4 and take the z coordinate to be 0, and that will give me 4. And I can get the same 4 and set the z coordinate to 1, and that will give me another 4. So total, I will get 8. Does it make sense? Okay, let me try showing it here. So corners of square, right? So it's 0, 0, 1, 0, 0, 1, and 1, 1. Okay, this is in the xy coordinate. You have x and y coordinate. Now corners of cube. You have x, y, and z. So what will we get? X and y have these 4 choices. For z, what should I do?
0, 1.
Yeah, can someone keep saying? What all can I write?
0, 0, 0, sir.
Yeah. Then
1, 0, 1, sir.
1, 0, 1. Okay. So simpler thing is just, okay, I just take these same 4 and I just put zeros everywhere in third place. Okay. And then I take the same same things, and then I just put a 1 instead of a 0. I just take the same thing. Okay. And this time I'll just put a 1. Okay. So from these 4, I got first 4 by just putting zeros, and the next 4 by just putting ones. So in fact, you can see even the same thing for square. The way you get the square, the reason you get 4 is because you can think about a one-dimensional square. What is a one-dimensional square? How many corners are there in a one-dimensional? So a square is a two-dimensional thing. If I were to draw something of a square in a line, in a single line, then what will I get? How many corners will I get? I will only have one coordinate. Okay, so if I just draw corners of 1D, one-dimensional, of a 1D square. Okay, so it won't be called a square, but one-dimensional of a 1 square. It's called a 1 square, I think. So it'll just have one coordinate. So I'll just take, since there has only one coordinate, I'll have only two possible values, 0 and 1. So in a one-dimensional square, you know how it looks? It just looks like it is just a line. So it's just a one-dimensional line, and you only take a point at 0 and a point at 1. That's it. So those are two corners of a one-dimensional square. And then the way you get a two-dimensional square is you go to 2 dimensions, and you take 0, 1. So you make 2 copies of this. You take a 0, 1, and in the y coordinate you put a 0, 0, either a 0, and again you take a 0, 1, you put a y coordinate, you got 1, 1. So you take 0, 1, and you get 2 copies of 0, 1, and it becomes a corner of a square. And then you get 2 copies of a square. If you take 2 copies of a square, you got a cube. So do you understand how you get from a single edge, just a one-dimensional edge, you make 2 copies of that edge along the y-axis. So take the x-axis, okay? So this is the x-axis, and I have a 0 and a 1 here. Now I make 2 copies. Now I make 2 copies of it along the y-axis. When I take 2 copies of this along the y-axis, I get a square. And then I take a square and I can make 2 copies of it along the z-axis. When I make 2 copies along the z-axis, then I get a cube. Does that make sense? Is that clear? How you get from a line segment, when I make 2 copies along the y-axis, I get a square. And when I take a square and make 2 copies along the z-axis, I get a cube. Is that clear to everyone? How I get 2 to 4 to 8 corners when I go from a line segment to a square. So line segment is exactly the one-dimensional square. And a square is a normal square is a two-dimensional square. And a cube is a three-dimensional square. Is that clear to everyone? Madhumita?
Yes, sir.
What is a one-dimensional square? How does it look? How does a one-dimensional square look, Madhumita? A normal square is how many dimensions? How much is a normal square? How many dimensions is that?
Sir, 2.
Yeah. How does a one-dimensional square look? So this is a one-dimensional square. Okay, just a line segment. And then this is a two-dimensional square. Okay. And then you can get a three-dimensional square is nothing but you take 2 copies of two-dimensional square and you connect them. So this can you see this? Can everyone see this?
Yes, sir.
Yes, sir.
So how many? So this is what we call normally a square. The middle one is what we normally call a square. Okay. Maybe one which is behind here. It won't be visible, so I'll dotted. Okay. So okay, let me not draw that because it's not be visible. So this is the normal square. Okay. This last one, what is it called normally? Normally, what do we call this? This last one, third one?
Cube, sir.
Cube. Yeah. Okay. So it's, but actually you can also call it three-dimensional square. Okay. The normal name is
Cube.
Cube. Yeah. Okay. And the first one, we just call it a line segment, right? But actually it is also can be viewed as a
One-dimensional.
one-dimensional square. Okay. Also called as a one square. I think we saw it in Wikipedia if you remember last time. And these are the, and each time you just double, you just take this line, and you make two copies of it along the y-axis. You take this one line along the x-axis, one and another one, and you just connect that way. And you take square and take two copies of the square along the z-axis, and then you connect them. So you get 3D square. And what are the coordinates? The coordinates are these. So if you just have one x-axis, then this is the origin in 0 and this is 1. So that's why the corners of the one square are just 0 and 1. The corners of the normal square, you have a z-axis also. So you just take this and you put 0 in the 0. Sorry, you have the y-axis also. So you just take this and you make the y-axis. You can put y0, y equal to 0, and do the same coordinates and you get y equal to 1. So you get 4 of them. And then you get corners of the cube. You just take these 4. You take two copies of the square and you check the z equal to 0 or z equal to 1. So you get 8. So how many corners will there in a 4-dimensional cube? How many corners will be there? Anyone? How many corners will be there in a 4-dimensional cube? Can anyone guess? Yeah. Now we cannot imagine a 4-dimensional cube, but can we write down the corners of the 4-dimensional cube? The 16 corners. Write down their coordinates. How will you write down the coordinates of that? So you have a x, y, z, and u coordinate. Four coordinates for each point. How will you write down these 16 corners? Four coordinates for each other. Anyone has any idea? See how I got the coordinates from? I went from in a one-dimensional square. I just have one coordinate. So I put 0 and a 1, like in a line segment like this. See, I just take a 0 and a 1. For square, I take a 0, 1. I'll take a 0 and a 1 in the first coordinate, and I'll make y equal to 0. And also I'll take 0 and 1 in the second coordinate. I'll put y equal to 1. In a three-dimensional cube, I'll take all the 4 corners of a square, and I'll put z coordinate equal to 0, and again take the same coordinates of the square, and I'll put z coordinate equal to 1. Okay. So each time I just get the coordinates of the next one by just taking the coordinates of the previous one and attaching a 0 at the end, and again just repeating the same thing but attaching a 1 at the end. So can anyone tell me how will I get coordinates for a 4-dimensional cube? Tell me any corner of the 4-dimensional cube. First, tell me any corner.
0, 0, 0.
Yeah, 0, 0, 0, 0. 4 zeros. Okay. Tell me one other corner. Yeah, correct. 0, 0, 0, 1. Okay. How many such? Tell me another one, Pooja.
0, 0, 1, 0, sir.
Yes. So like this, if you keep writing all the numbers, all possible combinations where you have either a 0 or a 1 in each position, how many combinations can you get? How many such combinations will you get?
16.
Pooja? 16, yes. So a simple way of writing the 16 is I just do this. I just repeat this part. I'll take this. So I'll just take. So here is a simple way of taking this. Okay, I'll just take corners of 4D cube. Okay, so just take these numbers and I put a. What will I put here? What will I put in the fourth position? What should I put here?
0, 0, 0.
0. I just put 0 everywhere. Okay, I just put 0 everywhere. Okay, and that gives me 8 corners, one set of 8 corners for the 4 cube. Okay, so these are 8 corners of the 4 cube. How do I get the remaining 8 corners? What will I do? For the 16 corners, I need another 8 corners. What will I do? How will I get the remaining 8 corners?
Again, coffee, sir, and add 1, 1, 1.
Add 1, sir.
Exactly. So I just take these same things. Okay. And let me just show it. Yeah, I'll just show side by side so that it's easier to make out then. So I'll just show the same thing and I'll just put a 1 at the 4th position. Okay. And let me just match them side by side. So these are the 16 corners of a cube, of a 4-dimensional cube. You just take the same 8 of them and you put a 0. You take the same 8 of them and you put a 1. Okay. And this way you can, so even though a 4-dimensional cube, when you say 4-dimensional cube cannot exist, means it cannot exist in this world. Okay. But mathematically it can exist. So we can talk about the corners, we can talk about distance between corners. We can even talk about the volume of like it won't be 3-dimensional volume, like just as square has area, right? Like a line segment has length, and then a square has area, and a 3-dimensional cube has volume, and a 4-dimensional cube will have 4-dimensional volume. So these length, square, length, area, volume, these are all just amount of space in a 1-dimensional object or a 2-dimensional object and 3-dimensional object. So the 4-dimensional object will have its own 4-dimensional volume. So you can talk about volume of that. And the reason we can talk about all these things is because mathematically we can talk about 4-dimensional cube and 4-dimensional sphere. Even though in real life we cannot create a 4-dimensional sphere. Okay. So it is not possible to make a 4-dimensional sphere, but it is possible. It is difficult to imagine a 4-dimensional sphere, but it is possible to mathematically talk about it. So in mathematics, they can exist. Okay, so these are some of the things we discussed last time. There's another thing we discussed last time. Okay, we were talking about waves. Does anyone remember what we were talking about waves last time? Who remembers about waves? We said that there was one particular graph whose graph exactly looked, one particular function whose graph exactly looked like a wave. Which function was that? What was the function whose graph looks like a wave? Something whose function goes, if you draw it, then it will go up and down, up and down, up and down. Remember what it was? Which function, if you plot it, goes up and down, up and down? It changes from 0 to 1. to 0 to -1 to 0 to 1. I can give you a hint. It is related to a circle. It's related to circle and angle. If I take a circle of radius 1 and I take that radius and keep turning it, I keep changing the angle, and I look at the height of that point, what happened to the height of the point as I change the angle? The y coordinate of that point, what will happen? When the radius is at 0 degrees, is along the x-axis, then what is the height of that point? What is the y coordinate of that point? If I take this radius is along the x-axis, then what is the y coordinate of that point?
So 0.
0, sir.
Yeah. What happens as I change the angle? What happens to the y coordinate?
Increases, sir.
Increases. Okay. As I keep increasing the angle, does it keep increasing? Or after some time it starts decreasing?
It increases up to 1, sir.
Yeah. When does it reach 1? At what angle does it reach 1? As I keep changing the angle, at which angle does the y coordinate, the height reach 1? At 45 degrees, what is the y coordinate? If I take the radius and the radius is 1, and I change it to 40, I change the angle to 45 degrees, then how much is the y coordinate? What is the y coordinate of the point on the circle, which is at along the 45 degree line? Of a circle of radius 1. No one remembers what is the coordinates of a point along the 45 degree line? Point on a circle along the 45 degree line? Don't remember?
So 1 by root.
Yeah, 1 by root 2. X coordinate is 1 by root 2, y coordinate is 1 by root 2. Okay. Okay, so you remember this we had this yeah, remember we were doing this 45 degrees. If this is 45 degrees, then this is also 45 degrees. So it's an isosceles triangle. And then we said, what is this? So this squared plus this squared has to be 1 squared, right? Because isosceles is a right angle triangle. So x squared plus s squared is equal to 1 squared. So x has to be 1 by root 2, which is about 0.707. Okay. So, which means that, so if I take a unit radius and I keep turning it at 45 degrees, the height will be 1 by root 2. At what angle will the height become 1? How much do I have to turn it so that the height of that point becomes 1? Sachin Kurabet, can you hear me? Sachin?
Yes, sir. Yes, sir.
Yeah. How much, at what angle will the height become 1? How much do I have to turn to make it the height 1?
And the radius also 1, sir.
Yeah, the radius is 1. Yeah. How much do I need to get turn so the height becomes 1? Height of this tip. Yeah, so if I just all I'm asking is this, okay? I have a circle, and this is the center. Okay, this point is the center, and this is the tip. So as I rotate this, I get the circle, right? Now
Yes,
here
sir.
the height of, if this is the x-axis, this height is, the y coordinate is 0. The height of this point from the x-axis is 0. Now as I make it 45 degrees, this becomes 1 by root 2. I have to keep, as I keep increasing the angle, the height goes on increasing. At what angle will the height become 1, Sachin?
90 degrees, sir.
90 degrees, exactly. Okay. So I have to make it 90 degrees, it becomes 1. Now, as I keep increasing the angle more than 90 degrees, what happens to the height? Does it increase or decrease?
Decrease, sir.
Decrease, yes. So up to 90 degrees, it goes on increasing. After that, it starts decreasing. Okay. At 180 degrees, what happens to the height?
0, sir.
Yes, 0. Okay. And then after 180 degrees, if I make it 3 times 90 degrees, 3 times 90 is 270 degrees. What is the height at 270 degrees? 3 times 90. Okay, so it's this is 190, this is 90, this is 180, and this is 270. What is the height at 270?
-1, sir.
-1, exactly. Okay. And then what is the height at 360 degrees?
1, sir.
When it's 360 degrees. 360 is
Zero,
what? 4
sir.
times
0,
0,
sir.
exactly.
0,
Yeah.
sir.
What about at 450 degrees? What is the height?
1, sir.
1, exactly. What about at 360 plus 45 degrees? So at 405 degrees. What is at 405 degrees? What is the height? 405 is exactly 360.
1 by root 2, sir.
1 by root 2. Yes. Because why? Because 360 will bring you back to this. 360 is actually same as 0. Okay. And 360 plus 45 is essentially basically same as 45. So it's 1 by root 2. So it goes on going from 0 to this 0 to 1 to 0 to -1. Now this height that I'm saying, as you change the angle theta, the height is changing. This height has a name, specific name. It's a specific function. What is the function called? Something of theta. What function is it? What is it called? If I rotate this by angle theta, the height is equal to some function of theta. What function is it? What is the name?
Cos theta.
The height is, what is the height called? Is the height cos theta?
Sin theta, sir.
Sin theta,
Sin.
exactly. Okay. The height is sin theta. The base is cos theta. Okay. The x coordinate, the y coordinate is called sin theta, and the x coordinate is called cos theta. Okay. So the sin theta, as you increase at the sine of 0 is 0. Okay. Sine of 45 degrees is 1 by root 2. Sine of 90 is 1. Then sine of 90 plus 45, which is 135 degrees, is again 1 by root 2. Then sine of 180 degrees is again 0. Then sine of 270 degrees is again -1. Then sine of 360 degrees is 0. Then sine of 450 degrees is 1, and so on and so forth. Okay. So it's sine theta. Now, do you remember what is the plot of y equal to sine theta? How it will look? How will it look? Y equal to sine theta. Can anyone tell how the plot will look? Who can tell how the plot of y equal to sine theta will look? So x-axis I'll put theta, and the y-axis is sine theta. Then how will the plot look? At 0 it will be 0. Okay. At 90 it will become 1. At 180 it will go back to 0. At 270 it will become -1. And then again 360 it will become 0. Again it will go back to 1. Again 1, 0, -1 like that. How will it look? Wave, exactly. Okay. And this is something we saw last time, right? So look at this. So this is y equal to sine theta. Okay. So it's y equal to sine x. Okay. So this is how it looks. It's like a wave. See, it's going from 0 to 1 to 0 to -1 to that. It's showing it at a different scale. Okay, is this clear? Why it is going up and down, up and down? Does everyone understand why sine theta keeps going up and down between -1 and 1? Is it clear to everyone, or anyone? Someone has any questions? So the sine theta is a very important function. Y equal to sine theta is a very important function. It is also called as a wave function. Okay, this is exactly the equation of a wave. Can you tell me some real life cases where such a function will come up? Can you tell me some real situations where you get this y equal to sine theta kind of, y equal to sine x kind of graphs? When will it come up?
Sine sound wave.
Sound wave. Okay. Where else?
The ocean.
Ocean waves,
Sea.
water waves. Sea, yeah, water waves. Okay. What else?
The carpet.
Carpet. Yeah. Okay. If I take a carpet and if I keep shaking like this, then the waves will form. Where else y equal to sine x kind of functions will come up? Can anyone tell specific cases where the sine x function comes up? What about a spring? If I have a spring, then what will happen? Like if I take a spring and I press something, it goes back and forth, right?
Yes, sir.
How does the sine thing come there? Can someone tell me what the sine, how I can get sine x there? You make x-axis as the time. You think of it as a function of time. Okay. So think about okay. Let's take a simple thing first. Okay. Let's say there is a ball that is going on a road, going sideways at a fixed speed. Let's say the speed is 1 meter per second. 1 meter per second. And I have time t, okay? Then can you tell me what is the distance traveled? So let's say the x-axis is time and y-axis is the distance traveled, or y-axis is how far it is from where it started, just how far it is from where it started, okay? So if the ball is going at fixed speed to the right at 1 meter per second, then can you tell me what function will I get? Y as a function of x. So x is time and y is the how far it is from where it started. If it's going at fixed speed, then what equation will you get?
Sir, y equal to x.
Yes, exactly. Okay. So because
Sir, because the ball travels in 1 second, it travels 1 meter. In 2 seconds, it travels 2 meters.
exactly. Okay. So if the ball is going 2 meters per second, then what equation will you get? What is the equation if it's 2 meters per second? Y is equal to
mx, sir.
Yeah, at 2 meters per second, what is it? If the speed of the ball is 2 meters per second, then how much? What is it? After x seconds, how far will the ball be? After x seconds. After 1 second, how far will it be?
2 meters, sir.
Yeah.
Y
2 seconds.
to x.
Exactly. Y is equal to 2x. Okay. Y is equal to 2x. Correct. And does anyone know if the ball is accelerating at acceleration a? Then okay. If the speed, just tell me first. It's not accelerating. Let's just say it's not going at 2 meters per second. It is going at v meters per second. V is the velocity of the ball. So can you tell me what is the equation you'll get? What equation will you get? Y is equal to?
Sir, repeat.
If it is going at v meters per second,
Y is equal to V of X.
v times x, exactly. V meters per second. So velocity of v meters per second, it will be, let's put it here. Okay. Vy is equal to v times x. And can someone tell me if the ball is actually accelerating with acceleration a and starting speed is u? The ball velocity, initial velocity is u meters per second and acceleration is a. Then can you tell me what will happen? Does anyone know this?
So it is
Have you
not
studied this already?
visible.
Not discussed? Not discussed? Okay, then you have not done what happens to a ball that is falling under gravity, how far
No, sir,
it
I
will be off
tried.
time. So here I just wrote that a ball is going to the right at 1 meter per second. X-axis is time, y-axis is how far to the right it is. So if it's 1 meter per second, you get y equal to x. 2 meters per second, you get y equal to 2 times x. V meters per second, you get y equal to v times x. Okay. Now instead, if I have an accelerating object, that means it's not going at a fixed speed. Okay, it's not going at a fixed velocity. So starting velocity is u meters per second, and acceleration is a. Then can you tell me what is the distance after time t or after time x? Have you studied this already? Uniform acceleration, have you studied it?
Yes, sir.
Yeah. Can you tell me the formula for distance traveled after time t or after time x?
Sir, the distance is equal to ut plus half at square.
Yeah. And now if time is x-axis x, then what is it? What will I write here?
Ux
Can you
plus
give me x?
half
Yeah,
ax square.
ux plus
Half
half
ax square.
a, exactly, ax squared. Okay, so since I don't have square, I'll just write like this. Correct? Now, do you know how the plot of this looks? Do you know how this looks, this plot? If I were to draw it, how will it look in a graph? So let me put u is equal to 1 and a equal to 1. So I will get if u's initial speed is 1 meter per second and a is equal to 1 meter per second squared, then I get y is equal to x plus x squared. Correct? So let's try to plot this and see how it looks. Okay.
It's a half.
So let me plot it. Oh, sorry, I forgot the half. Yeah, okay. So x plus 0.5 x squared. Okay. So let me go back here and okay, see this? So as x increases, this goes on. Actually, let me remove the initial velocity. It'll become clear, easier to see this. So let me make initial velocity 0. So it's starting at rest. Okay, then this x also goes away. I'll just get 0.5 x squared. So let's try to plot this one. Oops, sorry. You see this? So I change the initial velocity is 0. And so then the u also goes, the ux also goes away. I just get y equal to 0.5 x squared. And now let's go back to the plot. And let's remove the initial velocity, make the initial velocity 0. So you get this shape. See? So earlier y was equal to x, and now it goes faster and faster. So it goes farther, it goes more and more fast later. So it's covering more and more distance. And this equation, what is it called? Do you know what the shape is called? What is the shape?
Parabola, sir.
Exactly. Under uniform acceleration, an object, the shape, if you draw the graph, you get exactly a parabola. Okay. And we can continue next time. Okay. Thank you.